Janet's talk really also covered some aspects of taking risk, whether it was from saying yes to a project that had constraints that might make it a little bit scary, to hanging cables under some amount of tension above people walking beneath. And Jeff, I think, most viscerally had an element of risk in playing with a snake, poking it with a stick repeatedly. So without further ado, I'd like to turn this over to the second panel, which will be moderated by Maria Garlock. And she mentioned, for those of you who weren't sitting at that point, if you can go to pollev.com, CEE262, and answer this question of what are the risks or challenges of living at the intersection. And as you respond, you'll see your answer up here. You can also do it by text message. If you text to the address 37607, text CEE262, that will allow you to join this, and then just the second text can be your response.
Thank you. Before I begin, I want to introduce to you Paul Durst from the Council on Science and Technology, who assisted me with putting this panel together and will assist us as the panel emerges. And one of the first questions that Jeff asked his panel is, what does improvisation mean for engineers? And I didn't want to take away from the panel, but for me, it meant to, I'm an engineer, by the way. Okay, finding something new, getting fired, okay. That's good. Anyway, but for me, improvisation means learning to take comfort in taking risks, because improvisation is a form of risk. And I think we're going to hear that in today's panel, where the theme is the idea that creativity takes courage. So I improvised. You'll see Janet on stage. So I improvised at this moment because with Janet's talk, it was so inspirational. I saw so much risk. She risked so much in so many of her endeavors, and how she wove that into her life. I thought it was just so beautiful that it would be nice to hear from Janet on this topic of taking risks as well. So she, I'm grateful that she agreed to join this discussion. So one more thing. I feel a little bit like a hypocrite because I'm here to talk about taking risks, and what you're doing now takes no risk because you're completely anonymous, so it's not exactly about taking risks. But we did want to have an idea of what you're thinking so that the panelists in their response can consider your thoughts as they respond to your questions and even as they introduce themselves. So I'm not going to spend a lot of time introducing each panelist. I'm going to let them do that. They, in just 3 or 4 minutes each, with a few slides, introduce who they are and the work that they do. So you see that their work is in this context of taking risks. So we have on stage Jenna Eckelman, whom you heard her fabulous talk earlier, and Alessandro Beghini, who Jenna introduced as a collaborator. And then we have Taeyoon Choi, who's an artist and co-founder of a school for poetic computation. So it's a school that works at this intersection of engineering and art. And Becca Napolitano, who's a PhD student in the Department of Civil and Environmental Engineering, who also works at this intersection of archaeology and civil engineering. You'll hear about her work. And Bill Washabaugh, who is the creative director and founder of Hypersonic, who is trained as a mechanical engineer, worked at Boeing, and then decided to make a life change and become an artist in a studio with kinetic sculptures, more or less. So you hear from all of these panelists and what they do. All right, so I'll pass it off to Alessandro first. Okay.
Thank you. So. So I probably work in one of the most risk-averse industry, which is the civil architectural industry, because of all the what's at stake. I mean, there is clients, there is deadlines, there is money involved, insurances, liabilities, et cetera, et cetera. However, we have opportunities to do that. So we work on beautiful designs, and at least according to me, they're very quite beautiful. And what you see, for example, this is the LA Federal Courthouse, might seem like something that is conventional, but behind the facade, there is always some level of innovation, okay, always. And you know, whenever you talk about innovation, I mean, it's about, in a sense, pushing the boundaries of what the knowledge is at the time, pushing your constraints, and you get into uncharted territories, right? I mean, something that you have never seen before, inevitably. So to me, taking risk is really a state of mind. You know, it's just, it's about the understanding that the reality that is around us is not something that is set in stone. It's something that actually is very dynamic and is constantly changing. It's about being comfortable with the change and comfortable with the uncertainty, which is something that typically an engineer doesn't like, you know, because we like, you know, to think of a building, for example, of a structure, is something that I can design in a certain period of time. I'm going to design for certain loads. We have certain design criteria, and that's what I'm going to go for. So it's really the state of mind that is the understanding, the comfort zone, and also it takes a certain type of personality. And fundamentally, you know, I just say don't panic. You know, that's the worst thing you can do, panic or freak out. Doesn't help. It really doesn't help. So anyway, Janet talked about this beautiful piece of art that we worked together. And when you look at it, you know, you think about, you know, all the non-linearities that are in there. As an engineer, there is geometric non-linearity, there is material non-linearity, and so on and so forth. But, you know, there is non-linearities in the design process. There's no linearity in your life. I mean, if I look back at my life, I mean, it never happened that you go from A to B to C. It's not going to happen. You always go from A to E, and then you go back to A, and, you know, you spend so much time to think linearly that, you know, actually it would be much easier to think non-linearly, even though it takes a lot of risk. And it's about also people, ultimately, right? All the people that talk, you know, here earlier or that talk today, it's about, you know, they're likely-minded people, and there is passion, there is determination, because there is obstacles on the way as you're trying to achieve something. And so if you let the obstacles stop you, you'll never get there, right? And so this is a lot about, you know, taking the risk. And as I'm going through, these are just examples of projects I worked on with a number of artists. The previous one was Jamie Carpenter. This, for example, with Inigo, the Mass Mocha. And it's really changing your mindset, you know, working with these incredible, you know, and very talented people, and the way they think. Like, you know, this is from Mies van der Rohe's house, 24 by 24, a glass house, and thinking along their lines, you know, how, you know, for example, why would you attach the furniture to the ceiling and turn this house upside down? And, you know, it's really opening the opportunities of your thinking. And another important thought, you know, it's about the collaboration, and it's also about team making and team building, because this is the product of several people. And when it's important to have the right team and to choose the right collaborators, because it's, in a sense, you form a relationship, right? It's when you pick your girlfriend or boyfriend, husband, wife, you know. But, you know, if you want the sum of the components or the sum of the people to create something that is greater than just the algebraic sum, right, it needs to be the right people. Because sometimes I use the expression, you know, we think about work as something positive, generally speaking, energy-wise. However, there is what is called in human people negative work. I mean, if there is a team player, there is not a team player. It's actually more subtractive than additive, you know, to the sum of the components. So the people who are working are important for taking those chances. And another important component, I think, is dissemination of your knowledge. You know, the worst thing you can do is actually, sometimes, at least in our industry, is to patent an idea. Often, if you patent an idea, that's the easiest way to kill it, because no one is going to use it. So dissemination of your knowledge, publication, you know, these are some pictures from an exhibit that we just did in Chicago of our work at the crossroads of engineering, art, and architecture. So dissemination is important, and we spend quite a bit of time. And research as well, you know, internal research to develop new ideas that then can find a way into the mainstream of what we do. And with that, I just conclude my brief introduction.
Hello.
Yeah, oh, we have a clicker.
Hi, my name is Thien Choi. I'm an artist, an educator, an activist, usually in that order. So I'll talk about a few projects that I've been working on and the School for Poetic Computation. This project is called In Search of Personalized Time. And at that moment, me and my collaborator, Irun Kang, we were both working for a public art festival in South Korea. So we were jumping on these calls very late at night, 8 p.m. in New York would be 9 a.m. in Korea. So we would have these long, intense business calls, and it would come out of the call and be like, we don't know what time it is. And we need to find a different time zone that's between New York time and Korea time. So we thought, like, what if we make a clock that gives sense of, that gives form to your own sense of time? So these series of clocks are essentially timekeepers that you can initialize by pressing the button for what you think is a minute. And then the time proceeds based on that metric. We've had this very elaborate performative element at the Los Angeles County Museum of Art as a commission from the Art Plus Technology Lab. And the participants enjoyed the museum and the spaces based on their own sense of time. The game mechanics here is that we prompt them to come back to the gallery at the right time. But everyone's time was different. So we were able to drift between 30 minutes to hour and 30 minutes. So the project is, there's other elements to the project here too, but the essential point that I want to share with you is that to make this decentralized time, we actually had to use a very centralized mechanics. So we were communicating with the main server using GSM, which is essentially your cell phone, and tell the clock the right time, the correct time, which is a Greenwich Mean Time, and then calculate how much time it was different, how much of their personalized time was different. The second project is Incomplete Text in collaboration with Christine Sun Kim. And Christine's an old friend and a collaborator. She's born profoundly deaf. She works with sound in tangible ways. And she always wanted to work with metronomes. But as a deaf person, you can't actually use a metronome because the clicking sound does not signify, the movement does not signify the clicking sound. So I put a little piezo mic and then a small microcontroller. Every time that metronome clicks, it visualizes the sound as well. And we used the metronomes to synchronize the museum participants, museum visitors, as their own clocks as well, or their own devices of telling time. So we invited the participants to be choreographed into this collective movement using selfie sticks as the arm of the metronome. And it was a great experience because the audience were a mix of hearing and hard of hearing and deaf people, and we were able to create this common time together. So those are some of my collaborations, and my personal practice revolves around drawing, storytelling, and electronic hacking, programming, writing poetry. I want to talk about the School for Poetic Computation because I think it's core to the taking risk and the kind of interdisciplinary research that we're talking about. So I started a School for Poetic Computation with my co-founders because we were not happy in the way that we were teaching and the institutions that we were teaching. We were mostly teaching in private universities, and it's quite expensive, and it's not very accessible. So we wanted to see if we could build a very lightweight institutions that's accessible for students who may not be able to commit to 2-3 years in graduate schools. And I teach hardware like breadboarding, etc. My co-founder Zach Lieberman teaches software, and then we have a curriculum on poetry, craft, and critical theory. So philosophy and storytelling, as well as speculative fiction, and etc. It's a combination of research group, and then artist residency, and then a school. So our students are very diverse. We have students without high school degree, and we have students with PhD in computer science. So it's not actually a school. We don't give degrees. It's more of a collective residency, and we offer 10 weeks program in the city. Well, some of the projects that our students work on, this is a self-destructive machine where its installation itself tries to destroy itself, and it was a very interesting experience to watch this. I think one thing that I want to talk about is that a lot of the students come from years of engineering experience in Silicon Valley and such. And they come with this extreme exhaustion and questions about the ethical dilemma of their working for big companies that are making big things that we use. And as an educator, the challenge that I have is encouraging them to think outside of the technological industry, and then also to think of art as a space that they could explore their ideas. But the real challenge is to encourage them to do that outside of our 10 weeks program. And how do you become an artist? Like, how do you sustain your creative practice? And this is where the notion of code is really important. So, Michel Foucault would say in the society of discipline, which is a society of very strict rules and confined spaces. And Gilles Deleuze would also say the society of control, where it's a continuous forms of control. It's more like a highway that you pay the tolls to get into places, but you're always monitored. So the code is both the passcode as well as the computer code that define the interaction. So writing code is never neutral. Like, using technology is never neutral from the industry that gave birth to it, and military industrial complexes that supported the computations, research. So how can we unlearn the code? How can we use code for empathy and bring justice, and not just make giant machines that make more machines? This is where the uncertainty school that I co-founded, that I founded, begins. I just make institutions. That's what I usually do as an art form. So I just make schools and galleries and etc. So you'll just get used to it. So I work with museum educators and accessibility educators to think about how we can make spaces like this, academia and art spaces, accessible. So especially focusing on deaf, hard of hearing, and blind and autism spectrum folks, because they tend to be very excited about using art as a form of communication. And anything from literally providing code education in American Sign Language to thinking about the kind of the gender biases that are inherent in the computer programming languages, and the kind of violence that we sort of are complicit to when it comes to the technology industry. So it comes down to the last project, where it's called a distributed web of care. So I'm starting an initiative where it's focusing on P2P communication, so trying to bypass all of the Google and Dropbox and Facebook. But how do we communicate online without using those platforms? And I have a fellowship open for students at Princeton who you might be interested in, if you want to spend the summer with me and my team to think about how can we care? Like, how can we code to care and code carefully? So it's more than just engineering, it's like code of conduct. And how do we build a society of code that's different?
Thank you. Thank you very much.
So as Professor Garlock already said, I'm Rebecca Napolitano. I am a third-year PhD candidate in the Department of Civil and Environmental Engineering here at Princeton, but I work at the intersections of archaeology and engineering for most of my work. I am currently in a new lab here at Princeton called the Heritage Structures Lab, which is run by my advisor, Dr. Branko Glisic. And this lab, while it's seated within the civil engineering department, for every project we do, we collaborate with other departments here at Princeton, because we understand that the questions we're asking are not questions we should ask or answer alone. And so for a lot of our projects, we collaborate with the Department of Art and Archaeology on a large basis, as well as I saw some people from the Center for Digital Humanities here who have been a really excellent resource at helping us also tech up some of the work that we're doing. And in particular, for my dissertation work, what I'm trying to do is to develop tools to help people create 3D or virtual reality reconstructions of historic structures, because I know that not everyone would have all the tools you need in order to do that. And so I use my unique background. It's pretty weird. I was a double major in undergrad in classical languages and physics. I don't know how that happened, but I use both of those backgrounds now, which I'm still pretty excited about, in order to do my work. And the tools that I develop, they not only help us to understand what ancient people knew possibly about engineering or what they were actually constructing, or trying to figure out what the most efficient forms would be and maybe why people started to build, in this case, certain kinds of vaults because other ones were falling over. But also to get at other more interdisciplinary questions, such as how did engineering knowledge evolve over time? How did changes in a building either reflect changes in or alter human interaction? And how is knowledge, this is probably the more broad one, how is knowledge transferred between different societies and cultures? And so these are questions that I work at the intersection to try and understand. So as I said, for all of my projects, I collaborate with the Department of Art and Archaeology and the Center for Digital Humanities, because it's important that you work at this intersection. If I, just as an engineer alone, tried to build a digital reconstruction of a building in Rome, maybe I'd put in some type of arch form or some other type of structure that the Romans didn't know how to build. That came later in history, and that's not something that's in my expertise, which has now grown to be a lot of weird things, but it's not something in my expertise. And on the counter side, as an archaeologist, if they are learning how to make a 3D model and using their knowledge to make one, what happens if the structure that they build would never actually have stood? Then the conclusions that they're drawing for it aren't necessarily grounded in truth. And so how can we come together at that intersection to develop tools to enable that process to be relatively painless, so you don't have to have a degree in a bunch of random fields strung together to do it? But also, once you make those models, the questions that you can ask are so different. The project with the vaults that I'm working with a graduate student in the archaeology department on, I came to it and I was like, wow, it's really interesting. There's this different joint construction that's going on here. I wonder if maybe the other one was cracking and the Romans built this to try and avoid that. And she's like, interesting. I was wondering if this is because of the Trajannic legions and how they were interacting with the Parthians in this area. And I was like, oh, I never would have come to that question. But between the two of us, we're able to paint a more comprehensive picture and not just get a very myopic stance of these historic buildings, but to put them in the really holistic context that they're actually coming from. And so that's my work.
Thank you. I don't think I need that. We're going to give it a shot.
Come on, come on. Oh, man.
Oh, that doesn't look good.
We'll get there.
No, this is going to be great.
It's going to be great, guys. There we go.
Okay.
Oh, boy.
Hi, everyone. I'm Bill Washabaugh. Thank you guys for having me. It's great to be here, and I've enjoyed getting to hear everybody's sort of little talk about what they do, because it's fascinating to me. Maria, you told me I had 3 minutes, so I made a 3-minute video, and when it's done, I'll stop talking. But the video is really just sort of greatest hits of works that we've done in the last few years. So I founded this studio in Brooklyn about 8 years ago called Hypersonic. My background is in aerospace engineering, and so I used the name of the studio was a sort of nod to the class I did the worst in college, and I knew I'd never ever use it again, so that's why I named it that. But I left school, and I was really excited about airplanes and fluid flows and things like that, and I went in, worked for Boeing for a while, and I realized I don't get to make anything. I want to make things, and this is really boring, actually, because it's very careful and slow, and that's not what I wanted to do. And I didn't realize I took a risk, but I guess I did. And then I went to a different industry where I made big machines, and I got to make more stuff, but it still didn't satisfy my creative needs, which I was sort of always playing with at night. And I didn't realize the evolution of what I was doing, but I sort of quit my job and broke up with my girlfriend and left town and put everything in storage, and 15 years later, here I am, and I'm still trying to figure out what I'm doing. But we do large installation artworks, and a lot of them move. Even some of the ones that don't move do move. And so it's an exciting place for me to be here today, because I feel like I'm right at the center of this sort of integration of engineering and art. And that's really the foundation of my practice, along with this influence of nature. Super exciting to see your work, Janet, which I've seen a lot before, but like the same thing of how does nature influence what we're doing, and trying to bring this experience to people. And so, what else can I say? I have a couple risk questions that I've written down. which maybe we'll get to and maybe we won't, but the risks that I think of in the last 24 hours are relationships with people. I mean, a lot of this for me is about people experiencing the artwork, but the people I create the artwork with, and how does that relationship work and how do we maintain that? Spreading myself too thin. I'm trying to do so many things at once. I'm not good at any of them. I'm not a good artist. I'm not a good engineer, and all this happens by accident, in essence, and hopefully not a bad accident. So that's another risk. What if it breaks? All these things are really big and dangerous, and we do involve real engineers like yourself. But there's more that can break. It's not just the piece, but it's the experience. It's the understanding, and I'm really afraid of that. At the same time, I need to push the boundaries all the time, because I think that's what makes it successful. And then the last one that I have as a risk is money. I'm not supported by a university, so it's sort of a business, and it's sort of an artwork, and so how do we support that? And so that is something I deal with a lot. Those are my questions. Beyond 3 minutes, I'm sorry.
All right, thank you. So you can see the risks are different for all the panelists. But we found that, at least what I saw, and I had phone conversations with all the panelists before today just to get a sense for how they think and what they do. And one of the things that came out was this idea that taking risks leads to new opportunities. So if it wasn't for the risks that everyone on this stage took, the opportunity, this wonderful opportunity they have, it wouldn't have come through, and their art wouldn't come through. And I know Becca is still taking risks and hoping to come out on the right side of that in a few years. A job, yes. So taking risks leads to new opportunities, but also challenges. So would you mind addressing specifically what those challenges were? And Janet, this is the point where you're welcome to participate in the rest of the conversation. So who wants to answer that question first? What were your challenges?
Okay. Well, I mean, whenever we face a new project of art, or when you start exploring new boundaries, some of the biggest challenges is really the uncertainties. The number of uncertainties that you have to deal with. I mean, it's pretty wide. And for example, going a couple of examples, say ropes, right? I mean, it's not that there is a large amount of study in the literature about how do the rope behaves. I mean, okay, it's geometrically nonlinear. It's a material non-linearity, but typically in the literature you can find pre-cycled ropes, so you kind of get to the linear range. But the whole behavior of the braid is actually a very complex behavior. It's fascinating how complicated that is. And it was one of the biggest challenges is really trying to define what we're dealing with, or what kind of criteria are you even using to design? It's easy to say, I go to the design code like AC7, and you can find your wind loads, how much to design, wind, seismic. But performance criteria for a building, for your beam, how much needs to deflect, because your floor has to be relatively straight, right? I mean, you don't want to walk on a floor that is all over the place, right? But what's the design criteria for a piece of art? Especially a piece of art that is meant to move. So typically we want to restrain movement, right? I mean, we don't want building to move too much, otherwise, I mean, we make people nauseous, right? You don't want that. You want to control accelerations, right? But here we don't want to control it. We want it to move. And so it's the exact opposite thinking. So you need to rewire your brain to think in a completely different way. You also need to imagine what could happen, what can the sculpture experience? Is someone going to decide to climb the sculpture? I don't know. I mean, someone wants to hang from it. I mean, maybe you should design for it so that the sculpture doesn't come down if, I don't know, a 250-pound person is hanging from it. Probably is a good idea. So those are the challenges, just defining the problem. Sometimes, I mean, it's a big component of what we do, defining the problem, defining the criteria, and understanding really what you're dealing with in terms of material. So these are some of the challenges, and by pushing the boundaries of software, or you need to expect that something will go wrong. Okay, at some point it will go wrong. I mean, there's no way. I mean, if it never goes wrong, it means that you didn't push the boundary enough. That's the other way to look at it. you know? I mean, so you're gonna have to accept that the failure happened, but it's not a failure, it's something that you can learn from it, right? But, you know, validate things in multiple ways usually happens. You know, don't trust the computers too much. I mean, up to a certain level. For example, with Janet, you know, the testing that we did and the mock-ups, you know, trying, you know, to validate, you know, what the computer program gives you. I mean, that's one of the interesting part and one of the challenges and how we face them, at least from my perspective.
Yeah, I'd like to jump in on there, mainly because you said, are people going to climb it? Yes, they will. If they can, they will. I like the risks are sometimes in those unknowns, but it's a great. I've had a lot of these opportunities where we had literally a blank wall in one of these sculptures, especially the one that people wanted to climb, and there was it. I'm really afraid of a blank space because a lot of the artwork that I'm trying to do is very site-specific, and that to me represents constraints. And so you start asking questions. Okay, where are we? What are people thinking about here? What do I want to bring? Are there drunk college kids who will be here late at night? Things like that actually really help define what, to me, becomes constraints around what the sculpture is. And so actually we used that example of, like, they were very afraid of people climbing a sculpture, and we were like, oh, great, that's actually great. Let's make the lower part of the sculpture something you can't get your fingers into. And it brings a diversity into the sculpture that I wouldn't expect. And so I like the risks of an unknown space, but I like the constraints of just probing around that.
Thanks. Go ahead, Taeyoon. Go ahead. Well, Phil, one of the things you brought up during your introduction was you said, I'm not good at the engineering, I'm not great at the art, and so that breadth versus depth I've seen as a real challenge because I mean, I think that's something that most people try and figure out is that breadth versus depth ratio. But when your breadth spans across so many different fields, you can't see the other side of it. And so trying to figure out what you need to know, for me is a challenge, because I know going out of here, I want to be a professor, and so I'll probably have to have some pretty good depth in civil engineering. That's my field. But also for what I do, I have to have breadth in understanding Roman architecture and programming, and I've learned web development from the CDH. And so it's just, the challenge is trying to figure out what's a good point for you as a person for that breadth versus depth. And also, when can you just say, all right, this is outside of where I've been able to get to in my learning, and be comfortable, I mean, the best way I've done it is just continually surround myself with people from other disciplines and be very good at saying, you're the expert in this one, let me call on your knowledge. But I mean, for my work, that's something that I've just seen as a challenge, is trying to figure out what that golden ratio is for breadth versus depth.
For me, taking risk is slightly different. I see myself more as a social practice artist, and that means that I consider people's relationships and experiences as a medium. So for me, the sculptural elements are secondary to the experience itself. So for me, I think a lot about who I'm making work for. And it's not a mass or the public, it's individual people, it's a very specific community. I know them and I want to know them. That's why I make work for them. And when you work for a particular community, you have to be very careful about representation of who they are and their body and their identity. So the risk is about involving them in respecting their own dignity and their culture. At the same time, is making sure that you're never jeopardizing them and misrepresenting them. Because as an artist, you have so much power and privilege to present your ideas. But if people are involved, like, you're putting them at risk. So for me, it's about their dignity and integrity, as their personhood, and for as an artist, a mediator between them and then the space around it.
I enjoyed the questions that were up there about failure and risk, like lose your job, career suicide. I saw when people say, "Oh, failure is to be celebrated," I'm terrified of failure, just terrified. And I like that our culture is starting to celebrate failure, but I don't really believe it or trust it. And that's why and what does it mean to take risk, and how do you create places to fail where you don't actually fail? And that's one thing I'm learning, which is you build in prototypes into your timeline and your budget, that you have a place to fail and break before it's the one that counts, so that people aren't getting hurt. And so I think that, you hear all this la-di-da, failure is, success, and, but that's not really honest. Like, so what can we learn about how to create ways and places where you can fail before it is dangerous? And things that Alessandro and I are learning together, as we have sometimes taken on bigger challenges than we realized we were taking on at the moment, is we're trying now to push one variable at a time. That, like, when we get into trouble is when we're trying 3 different things that have never been done before all at once, and then, so that's, and then testing them, and even things that I've learned from Alessandro, because I am not coming from academia, as an artist, as Bill said, it's like we're our own research institute, but no funding, and so Alessandro, coming from an academic background, like saying, well, let's look at the research. And, we can reach out to this lab that's done a different thing, but maybe relative in the UK, or building in places to fail without actually failing when it counts, taking on one variable at a time, and then tolerances. So my software, for example, when we built that big piece in Boston, I considered that a success. It might have been a couple of feet off, but it didn't matter. But then we were installing the piece in the Smithsonian, and we went in, and it didn't fit. And we actually had to retrofit on site. And it was like, well, it didn't fail, but the tolerances now were less forgiving. And so one thing I'm learning with Alessandro in our collaboration is maybe what you do is you design your piece so that the result will allow you to adjust it. Like, so how do you design to have forgiving tolerances? Like, so your dance is unfolding, and they don't do, like last night, I understand things didn't go the way that they were expected to go, but I didn't know that. Like, the tolerances are more forgiving. And so maybe before we start the sculpture collaboration, we say, well, I want to be able to access it really easily so that over the next 50 years, if this is a permanent commission, we'll be able to get in there and replace one part. So sometimes maybe it's how you're framing it and thinking about it that means that you won't fail. So those are some thoughts. A practical point of view.
All wonderful points of view. Thank you. So another question of the fringe versus the intersection. So at some level, you're working at the edge of your field, this, like a fringe of your field, not really central to that field or profession. And then you move beyond that boundary, and you're in this intersection of engineering and art, so at the center of a new paradigm. So can you describe that to us? How do you know when you've removed yourself from that fringe and you're at this place, at this center? And how do you make your work at this center of this new paradigm impactful, and not just, oh, that's really nice or that's really cool, but really make it impactful? Maybe a difficult question, but do you have it?
I don't really have a good answer to most of your question, but I built a sculpture with my team years ago, and it was finished, and I was standing in front of it on the street, just in regular street clothes, and a guy walks by me, and he looks up and he goes, "Yeah, what's the point, right?" And I love that comment, because I knew we did push far enough, because I do want to have that moment where some people are like, "Oh, that's beautiful," and others were like, "I don't get that at all. What's the point?" And I think that's pushing the right level. And so there's something about making sure, to me, I want to keep pushing. I want 80% of the people to like it. But, and I actually really appreciated the uncomfortable moments in the dance performance last night for that reason. I want to feel that something's weird and incoherent. I like that moment.
Anybody else want to?
Sure, I can comment on that. I mean, for us, especially again, going back to an industry that, is not comfortable with change and the architecture and actual, practice of structural engineering, bringing some thoughts or some thinking, like, the type of thing we do with Janet, more towards the mainstream is very challenging, okay? And so you have to do it in small doses, okay? So small doses don't hurt anyone, and, people get used to that kind of thing that you're trying to communicate. And so it's actually great, experimenting with Janet, looking at new ideas, and you learn a lot from the process. And if you have enough vision, and we were talking about the breadth, of things that you can see. If you are up high enough that you have a vision of what's happening within the field or neighboring fields, right? Proximity, mechanical engineering, aeronautical engineering, art. If you have a vision of how you can take bits and pieces and take those and insert them progressively in small doses into your everyday life or in your project, then that becomes an innovation that is acceptable, palatable, for the contractors or the client, right? And it may not be, for example, a lot of people ask me, why don't we use ropes instead of steel cables, right? I mean, in normal construction for canopies, right, or other smaller projects. Well, there are challenges there, right? I mean, ropes have certain qualities. They're extremely strong, but their stiffness properties are not as reliable. Durability comes into play. So it's obviously not everything that we do can be applied to the mainstream, but some of it can. Like, for example, the type of analysis tools that we developed, I mean, can definitely be applied, or the design thinking can definitely be applied. So there are challenges there, but also I think there is ways forward as long as you have this vision of saying, oh, I can take that piece of knowledge and apply it here, right, in a completely different, context, right, and that advances the field.
Just real quickly, I think I'm still in the fringe, and I think and I think fringe is way more interesting than the intersection. I think it becomes really safe at intersection, and I'm a very vocal critic of art tech innovation narrative, because I think it's just serving the industry, and the narrative is not in the service of the arts. So I think fringe is cool, and I think we should always be in this fringe. But I know that I'm being heard when the industry or academia ask me what I think that they should do. Academia is desperate for guidance on what they should do and stay relevant. So I guess the challenge of being on the fringe is definitely the insecurity. I think that's real. I don't glamorize it, but I think experimental stuff is not really seen or published in a traditional sense or exhibited or recognized. But there's a value in just keep doing that.
Yeah, I agree. I feel like some of the work I'm still doing is at the fringe. I can go to a conference and someone says, we don't need to do structural analysis of everything. You just think that because you're an engineer. And I was like, but you're doing all of this work. You made this model of this building and you saw where a star hit the certain point of the building. But what if the building couldn't have stood that tall? And how does that change your conclusions? And so trying to recognize that there are going to be people who see your work as fringe, but to try and create space for yourself. So my collaborator and I, we went to this conference where we were told our work was cool or we didn't need it, and we just made our own session and tried to kind of just force our way into this space. And we're doing it at that level, but we're also doing a good job brainwashing children. So we try and take our work out. If we can't get the people who are already in the field to be extremely behind what we're doing, maybe we can change how the next generations in schools are thinking about these intersections, not just engineering and archaeology, but other intersections. So that way, it's not as hard for other people, and they can find new fringes, because there'll always be new fringes.
So some of you on the panel are educators, students, and I'm an educator as well. I wasn't trained as an artist at all, but I've learned over the course of being here at Princeton, because we embrace so much this intersection of engineering and art, to to really see and appreciate the art in the engineering. And I think that's of huge value. So for example, I see the Dreamcatcher sculpture, and not only do I see the beautiful nets and the colors, I see a Mitchell truss in there, right? So Mitchell truss is the most optimized truss form. So I look at that and I say, first the sculpture catches my attention, but immediately I say, that's a Mitchell truss, and I get really excited at the engineering behind the sculpture. So I have a kind of double appreciation for the kinds of work that you all do, because not only do I see the art, I see the challenge of the engineer behind that. So how, as educators, even if you're not educators, how would you encourage, or how do you help others teach in this way, especially with a curriculum in engineering in particular that's so constrained, where we have to meet all the ABET requirements, and you have just a challenge already to meet what's required by national standards for engineering discipline. How do you do that? How do you get somebody to appreciate this intersection in the artwork that you do?
You don't have to. I don't know whether to hold the mic or not.
Go for it.
Just a few comments. As a matter of fact, when I studied civil engineering in several countries at this point, so I've seen how it's taught. I studied in the U.S., in Italy, I studied in Japan for a while. And what I missed, I think, in my curriculum was really like more appreciation for the art, and the architecture, because as a civil engineer, like you said, we have to meet all these requirements, and you need to study mechanics of structures, or concrete, steel, all the traditional courses. But then, I mean, you go into the real life, and the real life, your technical knowledge is probably important up to maybe 20 to 30% of what you do. Right? I mean, 60 or 70% of what you do in your daily life as in a job is actually more related to human relationship, and something that goes beyond, just the technical, pure knowledge, and so it's very important to, to me, it would have been great, if during my curriculum I was reminded that there is more than just, there is more to engineering than just, a series of numbers. And I really wish that we can inject that, in the curriculum somehow. And it seems like with this effort, with this interdisciplinary course, I mean, maybe there is an opportunity there. But at the same time, as an engineer, I mean, I'm not an educator because I'm practicing. But I think as an engineer, we have, even a practicing engineer, you have this responsibility to share your knowledge somehow and emphasize the beauty that there is in a structure itself. I mean, structures are beautiful, in a sense. And, this knowledge, the Mitchell Trust, for example, it was an inspiration. And it's part of, what you can bring to the table in the collaboration with Janet, right? I mean, because the first time we met in Seattle, we went to see the Impatient Optimist at the Gates Foundations together. And it was the first time to meet Janet. And I remember, I mean, either in the car or somewhere, she said, oh, I want this piece to be about Dreamcatcher, right? And what do you think? And I said, okay, let me go back and think about it. And I'll Google it and see what happens. So I did that. I Googled it and I looked it up. I said, oh, I wasn't familiar with the Dreamcatcher, the iconography of the Dreamcatcher. And I said, oh, but I looked at the Dreamcatcher and then I saw the Mitchell Truss. I said, oh, this is the Mitchell Truss. That's interesting. Okay, the plot thickens. And so that's, how you appreciate that. But I wouldn't have gotten there unless, unless I met Janet and I thought about it and we proposed something. But I think, it's trying, even in my day-to-day life, with engineers and in the office, I mean, is really trying to emphasize and make them appreciate, these parts, that there is way more to engineering than just engineering and designing a beam. Is way more than that, behind it. So it's really, it's trying to make it part of your daily experience to me.
So yeah, I started teaching really early, right after grad school. So it's been already more than 10 years. And I teach at New York University's Tisch School of the Arts as an adjunct professor too. So I go back in between established institutions and DIY institutions. And what I think is most important in teaching is empowering students to be their own teacher. So I try to encourage students to think about learning after graduation and lifelong things. I'm inspired by Black Mountain College, which is an independent institution that existed for about 40 years. And the core statement of the Black Mountain is that a student, rather than the curriculum, should be the core of the school. And the second core argument is that teachers should be understood for what they do with what they know. So other than accreditations or academic standards, it's like what they practice. So practice itself as a teaching and the environment for learning. And when you help students to build this habit of making and learning and speaking out, they tend to create a habitat for their own creativity. And I think that goes beyond the walls of the classroom. And we can't expect students to be just in a very creative and independent environment. Sometimes they need to go into more restricted environment with constraints. And it's the empowerment for them to change those systems from inside is the really powerful thing that we could give as a gift for the students. And some of our students come from a very toxic industry that are dominated by powerful white men. And they ask me, should I go back and be complicit to that system, or should I make something else outside? And I can't answer that, because it's up to them. And I tell them that you should have an agency to go back there and then try to see what kind of culture you could create, work with that system, and create a very different environment for people like you to grow up. And become a support structure for other people, because we can't just ignore the problems that we have. And but if you want to create an alternative, you should also start to think about DIY approaches. And I think working with students, and students really find us as a sanctuary from those environments, and we try really hard to not replicate those models and different standards of appreciating everybody's work. And being in an environment where some people come with years of engineering experience and some others not, it's just really challenging to calibrate between the expertise and also enthusiasm for learning. So having a horizontal approach takes a lot of care.
I would also sort of encourage at this time, at the university sort of time, the opportunity for failure and exploration. I feel like that was foundational for me to get to where I've gotten, wherever that is I failed a lot and explored a lot and went along a lot of different paths. And I think that if there's a time for failure, and I agree, it's not when you're actually making the art piece, but it is now when you're able to study a lot of different things and find out what works and what doesn't, and you'll be amazed that later it's all very useful.
In the class transformations on Wednesday, students and Naomi were asking a question like, what is a collaboration? Like intersections, what is an intersection? What is a real collaboration? And I've been thinking about it since then, and I'm starting to think it's more about when you don't know how it's gonna turn out. Like the fake collaborations are when each person does their own thing and then the next person does their own thing, and they call it a collaboration, but it isn't really anything surprising. It's sort of like serial relationship or something, but then also, how do you create a chance for unknown to happen, like say the piece I was showing you where people pick a color and make a gesture and it's projected? Well, I pre-selected all the colors, okay? Like you get to pick them, but you can't pick any colors. So it's sort of like, how do you, because if you're gonna teach a class, you want it to be open, but you don't want it to become a giant mess. So therein is sort of a question, is finding that, like, how do you offer a set of unknowns, but yet make it sort of that all of them will be successful?
I mean, going back to teaching and how do we help others think about this space, Princeton, I know, has a lot of courses where they are engaging students at trying to not just stay within their rigid academic disciplines, but also to blend their coursework. I know you teach one in the spring. What's the official title?
Structures in the urban environment.
Structures in the urban environment, but you... Structural art. And you encourage your students to, it's the 3 E's. There's economy, efficiency, and elegance. I haven't taken the course, so there's no reason I really should know those. But also, in terms of elegance, you're talking to engineers and trying to get them to see structures for more than just simply supported beam, truss, solve this, reactions go, but to understand how people are going to use it, how people are going, what emotions it'll evoke. And so if you can, I mean, I think we're very fortunate at Princeton that we do that very inherently in a lot of our coursework. But if you can start teaching the students that this is just the normal way of thinking, that you shouldn't just be so binary, but the structures that'll make the largest impact in terms of civil engineering are the ones that really think about it from a holistic level. And if you can teach your students those same skills, you're normalizing it and you're helping to, again, further that space.
I think we're talking a lot about structures and spaces and taking spaces. I want to bring up this reference of artist named Simone Lee. Her last name is spelled L-E-I-G-H. She uses the term holding space as opposed to taking space. And she creates beautiful structures and sculptures, but her projects are vehicles for social engagement. And she's done a project for Black women's health, where it's a museum installation where it's a clinic for taking care of their body and issues that have been suppressed in the medical and kind of clinical institutions. So I think art and social justice is very, it could have a relationship that supports each other. And I think as much as we want to build beautiful stuff that inspire people, I think holding spaces for those encounters are equally important.
Thank you for your reflections on all those questions. We don't have much time left, but I do want to have an opportunity for the audience to ask questions of the panelists. No one's willing to take a risk and be the first one to ask the question. All right.
So I was struck today by Janet's work studying with masters of traditions that were passed down that have very strict histories. And something that I've always worried about with working with other people, especially given people's trends towards systems thinking, generalizing everything, is that you're going to be taking people's experiences and then just abstracting them to the point where they no longer have a place in history. I've felt that I was treading that line myself in my own work as an organizer. I'd speak to somebody who's an expert on housing, and then I'd bring it into my greater campaign model. And I'm trying to figure out how creating these intersections, if we want to use them that way, we'll be able to include everyone rather than just be a single point where people meet and no one really gets seen. Is that question coherent, or?
Well, I don't have an answer. Taeyoon? Okay.
Anyone in the
Yeah,
audience?
does anyone else have a good?
I mean, it was an open-ended question about how we can acknowledge, thank you. How we can acknowledge traditions that came before, techniques that came before, while creating these new spaces, these new ideas that we try to make them into things that were never thought of before, something new, exciting, but making that leap without breaking away from all the support that came into making it. I'm wondering how we can navigate that tension.
I'm not sure if this is directly answering your question, but the Mitchell Trust that we were talking about before is something that was lost to history for over 100 years. And at SOM, they're bringing forward all these old-fashioned, so to speak, techniques of structural analysis that were deemed, irrelevant. And they're showing, maybe you could talk a little bit about how they are actually absolutely relevant in design today. One is the Mitchell Trust, but I don't know if Alessandro, you want to mention
I
a few
can
more.
comment on it. There's, you're right. I mean, there are certain techniques, especially when it comes to computer modeling or analysis. For example, trust systems. I mean, we're not the first one to design structures. I mean, structures have been designed for many, many years, right? Maybe it was trial and error to start, which was kind of dangerous, obviously. But in the 1800s, they developed all these techniques like graphic statics. They go by various names. And then eventually they've been superseded by more advanced like computational methods like computer power. But now all of a sudden we say, well, we're kind of losing something, okay? Because the computer is actually often used as a black box, which is extremely dangerous, especially for an engineer. Because ultimately, you use a software, for example, okay? The first thing that you find in a software manual is a disclaimer that says that they don't take responsibility for what you're doing. So you're ultimately responsible as an engineer for what you're doing. You're stamping the drawings. And so, we started being cautious about, okay, shall we trust the computer or not? And, we discovered all these techniques that were used in the past to do calculations, okay, which were more graphical, or they allowed you to gain more insight. Okay, they were very, very insightful, and they would allow you to visualize things better. So we think that we can visualize things in a much better way today with a computer, but actually, in a sense, sometimes, at least in my mind, I mean, they kind of obscure your view, and they make it more difficult to understand certain things, while, these other methods, I mean, that we are discovering, it's really enabling you to better understand things, to see better, I mean, so there is a value there, I think, but obviously there is also tension in the sense that there is resistance in acknowledging that this technique have a value to them, right? I mean, because we are so, the mainstream is, oh, we use computer, you have something, if you don't know something, just mesh it or analyze it and put some boundary condition or some loads. It's it's going to tell you the answer, but the computer doesn't tell you the answer. It is helping you, but it's not really telling you what that's about. It's just different. So there is some tensions in that sense.
Yeah, and it's interesting, the technique that you're talking about, graphic statics, where it's a very visual method instead of like a finite element where it's a black box. That's what we're trying to implement for our tools for teaching archaeologists to think about structures. Because we're not going to say, go learn how to make a numerical model and know what it means, because some of my students in my statics class don't always know what the results of a finite element model are, because they haven't actually written the code for it. But if you can give someone a visual or an intuitive or didactic tool like graphic statics, which is a nod to how people were analyzing structures in the past, you can still get these new types of understanding from different disciplines, which I think is really interesting.
Yeah, just one quick. A friend of mine used to say, in case of doubt, mesh it out. It's not always the answer.
So I guess the long answer to your question was yes, there's huge value to bringing things from the past forward, and we're discovering that in different disciplines and in different ways. And am I out of time for the panel? No? Okay. One more question? Okay.
Hi, thank you. Do you think there are more challenges in getting someone with an engineering background to see the art behind structures, or do you think that there are maybe more challenges to getting someone with a humanities background to maybe see the engineering behind art, or is that not really a fair dichotomy to draw?
It's a fair question. Does anybody? I teach both engineering, so I could answer, but I'd rather the panelists. Janet, please go ahead.
Who cares? I don't know. If you go ahead and answer. I wanted to respond to a question that was posed earlier.
Please go ahead.
This morning, Ainsley and Jeff were sort of opening up the question of and actually Bill also, of what's the point, of this art making, and so listening to Taeyoon talk about one possibility is that it's creating a holding space, and I wanted to just bring in, it's a question, Sigrid mentioned I had been trained in clinical psychology, and when I was doing that training, they talked about how you create a temenos, a holding space, that what happens in psychotherapy is that you just create the holder. And so that's really an interesting thought, that maybe that is one thing that is occurring here.
Thank you. To answer your question, I think it's equally challenging. I think it just comes with different challenges, and I think it's about creating narratives around these disciplines that are very exciting. And a friend of mine, Amy Weibo, she goes by Sailor Mercury on Twitter. She makes these zines, like limited edition print zines, that are about computer concepts like compilers, or what is even a binary. And then it's all like cute pink and cats, and like really kind of very ornate. And she has a computer science degree, and she's worked as an industry engineer for years, and she still does not get considered as an engineer because she likes wearing pink. And her whole discipline is about making things pink, for like computer science to be pink. And I think that's a really good way of making things pink, but also making it exciting for people. So I think there's many ways of doing it both ways.
I want to apologize for being flip. I think I'm so frequently asked about the division between science and art, and I don't think there is a division. As if scientists and engineers aren't creative in their thinking, and as if artists aren't thinking about the physical properties of the world. So that was why that response came out. Maybe it's the way we think about that question that can change.
When you ask the question, are we at the fringe or the intersection? I wrote on my paper, I don't know and I don't care. I don't know where I am, but I just want to do the work that we're doing and have fun, and somebody else can answer that.
Yeah, I mean, I totally agree. I think when you're deep in your practice, you actually forget if you're doing humanities or arts or engineering, and those are the best places.
But I would argue that most students in particular think of themselves in one box or the other, and that it is a responsibility, I feel in a way, to tell them, no, there's no boundaries. I completely agree. You're both. And so that's one of the goals of the education, where I have students who are engineers and who are in the liberal arts, and I'm teaching them about how engineering can be art. And that's a huge message for the engineers, that engineers are creative beings, that you can be creative in your engineering, because they don't think of it that way. They think the structural engineer thinks we're enablers of the architect's dreams, but they don't think of themselves as creative. So bringing that message to the engineers is important. And then for the liberal arts students, it's important for them to understand the importance of engineering in the context of society. So that's my message to the other group. So I think it's important for them to understand that there are no boundaries, but they don't know that. My impression is they put themselves in one box or the other, and they have to put that label on themselves. And I totally agree that that's not true.
Yeah, in the realm of trying to teach both sides and what's more of a challenge, we just had a class which was half archaeologists and half engineers. And at the beginning of the class, one of the graduate students in archaeology is like, I'm sorry, but I haven't taken math in 10 years. And the engineer's like, what? How? But she's like, so can I ask questions about this though? And we're like, of course. And so it's about creating that space where your students can feel like they can ask a question, don't have to have qualifications to ask a question. And it's the risk of failure in creating a classroom where that's the best thing that you can have, because those are where the best questions come out. Because even the archaeologists were asking questions about the structures that we as civil engineers are like, oh, that's a good question. We should have thought about that. We should have had our hand up first. But it's all about creating the environment where both sides feel like they can engage with the material and not worry about what side they come from.
And I think to make that environment, you need to build a system of trust and respect for each other's expertise. So when a scientist just, comes to me and shows me a painting that they made in the Sunday, I'm like, that's really great. But when they ask me how would they show it at a gallery, I'm like, let's talk about it. and And so amateurism is very different from open collaboration. And I think the kind of environment that we are talking about is aware that you could come with your Sunday painting, but also we should be able to challenge them that this is not, they're not approaching in a way that the rigorously trained painters are approaching the same work. So yeah.
Thank you. I'm getting the cut sign from the gallery. So I want to thank the audience for your questions and especially the panelists for your discussion. Thank you. Thank you.